Thank you and good morning. As Alicia said, I am going to be talking about sediments from Antarctica. So I basically got to play with dirt all summer. Okay, so a little bit of a background on Antarctica is it's really cold, as we all know. It's really windy and it's very dry. It only gets between 3 and 50 millimeters of precipitation each year on average. It's actually a polar desert. That is how dry it is. And this area of Antarctica, the McMurdo Dry Valleys, is one of the few areas where there's no snow or ice. 98% of Antarctica is covered by snow or ice. So this is part of that small 2% that's just rocky and barren. It's a lot like this. This is a photo taken from the McMurdo Dry Valleys. I believe that this is the Commonwealth Stream. As you can see, it's really rocky. There's not a whole lot going on, but there's actually life there. There are microorganisms, lots of nematodes and tardigrades. So why do we care about this? Why did I play with dirt from Antarctica all summer? Well, like I said, there's life there. So how is it surviving? How is that life able to continue on? We need sunlight and water, but we also need vitamins and minerals, especially photosynthetic organisms. They really need things like iron. So where is it getting some of these nutrients? Well, we get a lot of ours from the soil, so they probably get a lot of theirs from the soil there. So I looked at how the stream is weathering those sediments down. So physical weathering and chemical weathering are the two different things that are going to be breaking down those sediments. Physical weathering is just when those sediments are rubbing up against each other, breaking down into smaller pieces. Chemical weathering is when there's an actual chemical reaction happening that is starting to break down the sediments on a molecular level. Okay, so my samples, as I said, were taken from the McMurdo Dry Valleys, and there are 3 main valleys there, from north to south, and the Taylor Valley is one of them. And in the Taylor Valley, there is a number of streams, and mine were taken on the northeastern side of the valley from the Von Gerard Stream. So here is a couple of images, an image from the sample site and a map showing them. So there were 3 sample sites. The first one being down there. That one is the second and the third. These were taken from meandering parts of the stream, so sites where the stream is going to go back and forth and back and forth. And these were chosen for my samples because I thought that I would have a greater diversity in the grain size distribution. And as you can see in the photo here, the samples were taken cross-sectionally from the stream, so they would start on one side where the soil was like starting to get damp from the stream, all the way across to the other side where it was the end of that damp sediment. So first I had to dry my samples because they came from a stream, so they were very wet. And then I spent a month sieving them. And then I picked out the samples I was going to do further analysis on, and I ground them up by hand and just making sure that's known. And then I did an XRD analysis, and XRD is X-ray diffraction. It is a test to figure out the mineralogy of the sediment. Okay, so the grain size analysis, that is the stack of the sieves that I used. And then these are the different soil classifications, so like the gravel size, the different sands, and then the silt and the clay being like the smallest and the finest. So this is the grain size distribution that I found, and you can see from upstream to downstream, so that first site location, there's a lot more of those like gravel type sediments and those coarse sands, significantly more at the beginning of the stream. And there's really not a whole lot of the fine sediments, not a lot of the silt or the clay. The second location, a little bit further downstream, it follows about the same pattern, but there's definitely less gravel, less of the coarse sands as well. It has slightly more of the silt and clay. And then at the last location at the end of the stream, that is where we see the most significant difference. There is not a whole lot of the coarse sediments, but there's a lot more of those fine sands, and a lot more of those clays and silts. Okay, and then the mineralogy, the XRD testing, I broke it up, my samples that I chose, into their coarse sizes and the fine sizes, because I wanted to see how things were breaking down. And one of the things that I noticed was the quartz in my samples. So in the fine and in the coarse and the fine, I found quartz, and the percentages were about the same. And that makes sense because quartz breaks down physically. It doesn't break down chemically. So it's just going to break down into smaller pieces. So you would expect the percentage to be about the same for wherever it is in the soil. And then another thing that I noticed was the presence of hematite and pyrite, or fool's gold. The reason why these are important is because you can see that they're in the coarse size fractions, but they're not in the fine size fractions. And why we care about this is because hematite and pyrite, they break down chemically. So hematite, it's iron oxide, so as it's weathered away in the stream, and it's weathered very easily, it's going to break down and it's going to let some of that iron into the stream and into the ecosystem. And then pyrite is iron sulfide, so again, as it's breaking down, you're getting some of the iron, but you're also getting sulfur, which is also really important. And both of these, like I said, have iron, and as I said earlier, that is really important for photosynthetic organisms. So what I found out is, yeah, there's a lot of physical and chemical weathering happening in these streams. They only flow for 4 to 12 weeks of the year, so it is really important for the living organisms in Antarctica for these streams to be breaking down the sediments and giving them the nutrients that they need. A lot of this was very preliminary research. Not a whole lot has been done on the streams in Antarctica and about the physical weathering there and the sources of nutrients for the organisms. So there's a lot of different ways that this research can be taken. And thank you to everybody in my RECCS cohort, and Hannah and Alicia and all my mentors for helping me out this summer. I'm kind of sad to see it go. And there's a QR code with all of the papers that I read this summer. There was so many of them. Okay, any questions? No? Oh?
So there's like water streams in Antarctica?
Yeah, it's not all ice. When the glaciers melt, and this only happens for a little bit of time, during their summer, like they'll melt and the streams will go for, like I said, 4 to 12 weeks out of the year. So it's like such a small window. So the life that's there really depends on that like small source of water. And the streams are very thin. In that earlier photo where the people were like collecting the samples, like it's just like a trickle of water, but it's just crucial for the environment there. It's still very cold. It's still very, very cold. Yes.
I noticed that a lot of your samples were taken from like right at where the stream was, that like M3-3.
Oh,
area.
the XRD?
In the transect, yeah.
Yeah.
Why did you choose that spot in like the middle of the stream instead of on either side?
I decided to display the XRD analysis from the center of the stream because I thought that that would be a little bit better, that would give me a clearer view of the the different minerals that were in the stream, because if it's on the side, the finer sediments, they're going to be deposited on the edge as like the stream kind of like bends, it's going to deposit those fine sediments. And as it goes this way, fine sediments there. So in the middle is where I was going to get a lot clearer view of the mineralogy of those sediments in the stream. Yes, these samples were collected in 2019. I believe, I don't know who was pictured in that photo, but I know that some of the people who were there was Kathy Welch, one of the grad students, Anna, and a few other people who went down. But yeah, these samples. Yes, yes. Yeah, this is, the team was an in-star team, so yeah, part here from Boulder. Anything else? Okay.
Let's go, Izzy! I'm excited.
Just gonna put that right there.